So we'll start with the class. Okay. So last class we were discussing the in-text questions. So we have completed chemical equations, right? The chapter has been completed, chemical reactions and equations. So we were discussing the in-text questions. So we have discussed those few previous questions. Okay, so these were the questions which we have already discussed in the last class. So now we'll go with the fifth question. So our fifth question is, why does the color of copper sulfate solution change when iron nail is dropped in it? Yes, why does the copper sulfate solution change when you drop a iron nail in that? Why the color changes? Yes, Shreya, can you tell the answer? Yes, so here the displacement takes place. Okay, so what happens here? So so that when iron nail is dipped, so this is an example of a displacement reaction. So when the iron nail is dipped in the copper sulfate solution, so what happens? Iron will displace the copper which is present from the copper sulfate solution. Okay, because what is happening? Because which iron is metal, so in displacement reaction the more reactive metal will get displaced. So here iron is a what it is highly, or it is more reactive than copper. So iron, it gets displaced, okay, from the copper sulfate. So thus the color of the copper sulfate color of the copper sulfate solution changes. Okay, so how does this reaction takes place? So I'll write the equation. How does the reaction takes place? So Fe, is, that is, you're dipping the iron in the copper sulfate solution, that is copper sulfate, giving you what? Giving you FeSO4. Because what is the reason? That is, iron is more reactive. It is more reactive than copper. Okay, so the color changes. So color of the copper sulfate solution changes because iron metal is highly reactive than that of a copper sulfate So the copper, it gets displaced, iron get displaced with copper from the copper sulfate solution. So this is the reason. Okay, so this is our fifth question. Next we'll discuss the So next question is, give an example for displacement reaction. So what example you can give for displacement reaction? So what example you can give for displacement reaction? So I'll write the displacement reaction example. Okay, so what is displacement reaction? So I'll give a reaction of, so I'll write it here. Okay, AgNO3 plus NaCl, giving you AgCl plus NaNO3. Okay, so this is the displacement reaction. So you can see here AgNO3 is there. So what is getting displaced? So your NO3 is getting displaced with Cl, right? So this is double displacement reaction. So what is happening here? The reaction is between silver nitrate. So this is silver nitrate and this is sodium chloride. This is sodium chloride. So giving you what? Giving you silver chloride and NaNO3. Okay, NaNO3. So this is so this is an example of double displacement reaction. So during the reaction, the negative and the positive ion will change the position as a result of the formation of white silver iodide. So this is silver chloride. So this is silver chloride and this is sodium nitrate. So this is an example for your double displacement reaction. Okay, so we'll go for the next question. Next question is, you have to identify the substances that are oxidized and the substances that are reduced in the following equations. Okay, so you have to tell what is oxidized and what is reduced. So first equation 4Na, okay, plus O2 giving you 2Na2O. So here what is happening here? Na. So in the first equation, the sodium in the first equation is getting what? It is getting oxidized. Okay, it is getting oxidized with the addition of oxygen. So when you are adding oxygen, what it will become? It will undergo oxidation. And in the second case, so this is, it is getting oxidized. Why it is getting oxidized? Because you are adding your oxygen. You know, addition of oxygen is what? Addition of oxygen is oxidation. So in the first reaction, it is undergoing oxidation. Then in the second reaction, CuO, okay, it reacts with what? It reacts with H2. So in the second equation, it is getting reduced due to the addition of hydrogen. So addition of hydrogen is what? Addition of hydrogen is your reduction. Understood? So these were some of the in-text questions. This is clear? Yes. Okay, so this is one is getting oxidized, another is getting reduced. What is the example? So when you are adding oxygen, it will undergo oxidation. When you are adding hydrogen, it will undergo reduction. Okay, so these are the examples of oxidation and reduction. Understood, Shreya? So we'll continue further. Okay, so next is, so these are the exercise questions which are behind your this, okay, exercises. So these are the exercises question which are behind your text. So we'll go through that now. So the first one is, which of the following, okay, which of the following statements about the reaction below are incorrect? So the reaction is given here. So you have to tell which of the statement about the reaction below is incorrect. Okay, so this is the reaction 2PbO, that is lead oxide plus carbon, giving you 2Pb plus carbon dioxide. Okay, so this is the reaction. So this is the reaction. So you have to tell. So A options. So these are the statement given. First statement is lead is getting reduced. B, carbon dioxide is getting oxidized. C, carbon is getting oxidized. D, lead oxide is getting reduced. So which of the statements are incorrect? So in one first option, so these are the options. Okay. So these are the options. So these are the options. So 1, A and B, second, A and C, D, A, B, C, and fourth, all. So you have to tell which among the following is incorrect. Can you tell the answer? Yes. So which, so seeing the reaction, you have to tell which among the following is incorrect. Okay. Yes. A and B. Okay. Okay. So what is the explanation for this? A and B. Just a second. Okay. So the option here is which one? It is option number 1. Okay. That is A and B. So A and B, because oxygen is oxygen here is removed. You can see here oxygen is present in what? Oxygen is present in your what is that? Reactant size. Okay. And in the product side, oxygen is been removed. So oxygen is removed here. So this is the one reason. So A, that is lead, is getting reduced. It is wrong. Okay, because oxygen is being removed. So then second is what? Because the removed oxygen from lead is added to the elemental carbon. So here you can see that from the carbon, here there is no oxygen here, but in the reactant side, oxygen is added. So carbon dioxide is getting oxidized. Okay. So these two options below are incorrect. Okay. So we'll go for the next one. The above, so Fe2O3 plus 2Al giving you Al2O3 plus 2Fe. The above reaction is an example of A, combination reaction, B, double displacement reaction, C, decomposition reaction, and D, displacement reaction. Yes. So this is a reaction. You have to tell what is getting. So here you can see Fe is getting displaced with Al, right? So Al is getting displaced with Fe. So this is an example for what? It is an example for displacement reaction. Understood? So Al here, Al, no, not option B. It is D, displacement. Double displacements means two, this should get displaced. No, here only Fe is getting, that is Fe is, Al is getting displaced with Fe. Okay, so only one displacement reaction is taking place, right? So this is displacement reaction. So here the oxygen from the ferrous oxide, you can see, is getting displaced to the aluminium metal to form aluminium oxide. So in this reaction, the aluminium is more reactive than that of the iron, metal iron. So aluminium will displace your Fe from its oxide. So this type of chemical reaction is called as what? Displacement reaction. So in which one of the element will get displaces with the another. So your less reactive metal is displaced by the more reactive metal. So here only one time displacement is occurring. So it is called as the single displacement reaction. Okay, so only your aluminium Fe is getting displaced by aluminium. So there is only one single step displacement taking place. So it is a displacement reaction. So option D. Okay, option D is the answer. I hope it is understood. So we'll go for the next one. So what happens when dilute hydrochloric acid is added to iron fillings? Okay, iron fillings. Tick the correct answer. A, hydrogen gas and iron chloride are produced. B, chlorine gas and iron hydroxide are produced. C, no reaction takes place. D, iron salt and water are produced. So what will happen here? So if I write the reaction, what they have told, what happens when hydrochloric acid, or what is hydrochloric acid? HCl. When it reacts with iron is what? Fe. What it will form? It will form FeCl2. Okay, so this will should take 2. So FeCl2 plus H2 gas. So here what you are getting? So hydrogen gas and iron chloride are produced. So option A. Okay, option A is the answer. Okay, option A is the answer. So you can just make note of this. Okay, so what happens when hydrochloric acid is added to iron fillings? So you get here. So this is hydrogen. Our products are hydrogen and hydrogen gas. So this is hydrogen gas and iron chloride. Okay, and iron chloride. So these are the, so this is the what you say, so this is the product which we are obtaining. Okay, so this is clear. Okay, so we'll go for the next question. So what is balanced chemical equation? Why should chemical equations be balanced? Okay, so this is the question. What is balanced chemical equation and why should chemical equations be balanced? So the answer is a balanced equation is one in which number of different atoms on both the reactant and product sides are equal. So balanced chemical equation means what? It is number of so it is one balance equation is one in which the number of atoms on both the side, okay, of the reactant and the products are equal. Okay, so balancing chemical equation, why it is necessary? Why should we balance the chemical equation? So the second question, the answer for second question is balancing chemical equation is necessary for the reaction should obey the law of conservation of mass. That is, balancing the chemical equation has no defined method and is purely a trial and error attempt. Okay, so balancing the chemical equations, so it should follow, it is following the law of conservation mass. That is, matter not be created, not be destroyed. Okay, so that is because of that you have to balance the equation. So balancing the equation is not a method, you are doing a trial and error method. So this is balanced chemical equation. So in balanced chemical equation, the number of atoms, the different atoms which are present in both reactant side as well as the product side, they should be equal. So this is balanced chemical equation. Then next question, translate the following statements into chemical equations and then balance them. Okay, so you have to translate the following statement into chemical equations. You need to write them, the chemical equations for the following statement, and then you have to balance it. Hydrogen gas. Hydrogen gas means H2. Okay, it combines with nitrogen. Nitrogen is N2. Okay, to give you ammonia. So ammonia is NH3. Okay, now balance the equation. Here it is 2. Here it is 2. Okay, so here I'll make it 3. Okay, so this becomes 6. So this becomes 2. Is it balanced? Can you see now? So 3 to the 6 here. This is 3 to the 6. Nitrogen is 2. Nitrogen is 2. Okay, so like this, you have to balance the chemical equation. Okay, then next is hydrogen sulfide gas burns in air to give water and sulfur dioxide. Hydrogen sulfide is H2S. So H2S gas, it burns with air. Air means what? Air means oxygen. Okay, air means oxygen. It gives you what? It gives you water and sulfur dioxide. Sulfur dioxide is SO2. Now we'll balance the equation. H2 is H2 here. Oxygen is how many oxygens are here? 2. Here there are 3 oxygens. Sulfur is 1. Here is sulfur is 1. So how do you balance this now? So if I want to balance it, sulfur is how many? Sulfur is 1. Oxygen is 2. Right. So first I will balance the oxygen. So if I take here 3 to the 6, this becomes 3. So I'll write here now 2. Okay, 2. Now this becomes how many? 2, 4, 2, 4, 5, 3, 4. So here again 2. So 2 to the 4, 4 and 6. Okay. Now just see oxygens are how many here? Here oxygens are 2 to the 4 and this is oxygen is 6, hydrogens are 4, sulfur is 2. That side hydrogen is 2, sulfur is 1, oxygen is 6. Now what all is balanced? Oxygen is balanced, hydrogen is also not balanced. So if I write here 2, so this will become 4, this will become 2. So now that is balanced. So our equation is what? Our equation is this. Okay, our final equation is this. Understood? Yes. Plus 3O2. Understood? Balancing is very important. Okay, balancing is very important. So next question, this statement that we have to convert it into chemical equation is barium chloride. Barium chloride is what? BaCl2. Barium chloride, it reacts with aluminum sulfate. Aluminum sulfate is what? Al2 SO4 thrice. Aluminium. I've told you how to write. Aluminium is Al plus 3. Sulfate is SO4 minus 2. Now there are unequal charges. So I will write the charge below. Then I will crisscross it. So it will be Al2 SO4 thrice. So if how to write the formula directly. So this is the way. So barium chloride. Barium chloride is Ba plus 2 and chloride is Cl minus 1. So again unequal charges. So Ba2 Cl minus 1. So not minus 1, just write 1. Then BaCl2. Understood? Like this. So BaCl2 plus aluminum sulfate giving you what it will give you? It will give you aluminum chloride. So that is AlCl3 plus barium sulfate plus barium sulfate. So this is the equation. Okay, now we have to balance it. How to balance it? Barium are how many here? Barium is 1 here. Here barium is 1. Chloride are 2 here. Here there are 3. So first I will balance the chloride. So this becomes 3. 3 to the 6. Okay, 3 to the 6. Now here aluminum chloride are 3. So I'll balance this by 2. So this becomes 6 now. Now aluminum are 2. Here aluminum are 2. Sulfates are sulfate here it is Al2SO4 thrice. Now here barium are 3, here there are 1. So this here also I'll write it as 3. Now if you see it is balanced. Okay. So now it is balanced. Okay. So here this is the way you're going to balance it. So this I had erased it. It is H2S plus 3O2 giving you 2H2O plus 2SO2. So this was the balanced equation for this particular statement. Now the last here, potassium metal. Okay, potassium metal means K. It reacts with water to give you potassium hydroxide. Potassium hydroxide is KOH plus H2 gas. Now you balance it. Now balance it. So K is K1. Here K is 1. Oxygen is 1. Hydrogens are 3 here. Okay. So how we have to balance it? You will write here 2. So 2, this will become 2. Okay. So now just see balancing 2K, 2K. Oxygens here are 1. There are 2 oxygens. So again I'll write here 2. So 2 and here 2. Hydrogens are 4. Hydrogens are 4. So now it is balanced. Yes. It is balanced. Understood? Understood till here? Clear till here? Yes, so these are the exercise questions which we are solving for those who have come late now. Okay, so these are the exercises question. We have finished the in-text question, remaining questions. Then we have started with this exercises question. Okay. Next question. So now you need to balance the following chemical equations. Okay, so these are the chemical equations you have to balance. Now, now I want you all to balance this chemical equation. Okay, one of you take A, B, and C. Okay, one each, and then you can solve it. Who will take A? Who will tell one? You have to balance the following equations. How to balance it? How will you balance it? Yes. Balance it. Hydrogen is how much here? Hydrogens. Hydrogen is 1 here. Here not one. Hydrogen is 1 and here 2. So it is 3 hydrogens and here hydrogens are 2. Then here nitrogen is 1. Here nitrogen is 1. Oxygens are 3, 4, 5. 5 oxygens. Here oxygens are 3, 2, 6, 7. 7 oxygens. Then here calcium is 1. Here calcium is 1. Then, okay, finished. So now you have to balance it. How will you balance it? So HNO3, here there are 3. So if I write here 2, okay, and here if I write it 2. So this will be 2 hydrogens plus here 2. 2 plus 2, it becomes 4. So here it becomes 4. Then here 4. So hydrogen is balanced. Now nitrogen becomes 2 here. Here nitrogen becomes 1 only. Then oxygen, we'll see oxygen. Oxygens here are 3 to the 6. 6 and this 6, 7, 8. 8 oxygen. This side 2, 3 to the 6, 7, 8. Here also 8 oxygens. Okay, oxygen and hydrogen is balanced. Now we'll balance the nitrogen and calcium. So calcium and nitrogen, how we balance 2HNO3 plus CaOH twice, giving you CaNO3 twice plus 2H2O. Ca is how much? 1 here. Ca is 1. Nitrogen is 2. Here nitrogen is 2. Nitrogen here is also 2. Okay, so nitrogen is also balanced. Oxygen is 8, balanced. Calcium is balanced. Yes, so the equation is balanced, right? So the equation is balanced. So 2HNO3 plus CaOH twice gives you CaNO3 twice plus 2H2O. So this is a balanced equation. Understood? Okay, so you have to balance it. So on the both the reactant as well as product side, it should be equal. Now next is NaOH plus H2SO4 giving you Na2SO4 plus H2O. How will you write it? Okay, Na, I'll just clear this. So Na, Na. Na is how much here? Na is 1 here. Here Na is 2. This side oxygen is 5. Here oxygen is 4, 5. Okay. Hydrogens. Hydrogens are 3. Here hydrogens are 2. Then sulfur is 1. Here sulfur is 1. Okay. Now see. So nitrogen is not... so sodium, here 1, here 2. So I can write 2 NaOH. 2 NaOH means now Na becomes 2 here. So Na is balanced. Now oxygen is how many? 2 plus 4 is 6. This becomes 6 now. And here there are 4 plus 1, 5. Now how I'll balance it? I'll add 2 here also. So now it will become 2 plus 4, it will become 6. Now hydrogens, come to hydrogens. 4 hydrogens here will become 4. And here hydrogen will become 2 plus 2, it will also become 4. What about sulfur? Sulfur is 1 here, sulfur is 1 here. Okay, so the equation now is balanced equation. Yes, now this is a balanced equation. So now this is a balanced equation. So next we'll go for the next one. Okay, next equation, NaCl plus AgNO3 giving you AgCl plus NaNO3. Now Na is how much here? Na is 1. Here Na is 1. Then Cl is 1. Cl is 1. Then Ag is 1.
Equation is already balanced.
Yeah, that will I'll check now. Then Ag is here 1. Then Na is 1 here. Here N is 1. Oxygens are 3. Oxygens are 3. Yes, this is a balanced equation. Okay, so this is a balanced equation. Already the equation is balanced. Okay. So we'll go for the next one. So next equation, BaCl2 plus H2SO4 giving you BaSO4 plus HCl. Yes, now just check both on the reactant side and the product side. So Ba is how much? Ba is 1. Ba is 1. Chlorides are 2. Your chloride is 1. Then hydrogen is 2. Your hydrogen is 1. Then sulfur is 1. Sulfur is 1. Oxygen is 4. Your oxygens are
The
4.
equation is BuCl2 plus H2SO4, BuSO4 plus 2HCl.
Yes. So it will become 2HCl because barium is there. Only we need to what we have to balance our chlorine. Okay. So it becomes 2HCl. So once you balance your here, so automatically hydrogen also become 2. Okay. So this will become 2. This will become 2. So this is the balanced equation. Okay. So I hope this is clear. So like this, you have to balance the given equations. So we'll go for the next one. Okay, write the balanced chemical equations for the following reaction. Now we have to write the equation. They have given the statement in the form of statement. We need to write the equations. Okay. So calcium hydroxide. How do we write calcium hydroxide? Calcium hydroxide is CaOH twice. Okay. Calcium hydroxide. Now calcium is what? Ca plus 2. Hydroxide is OH minus. Now whenever you have minus means 1, minus 1. Whenever you have this what unequal charges, the charges are not same, plus 2 minus 1 no, both are different. One is plus 2, another is minus 1. So I'll write the charge below. So this will be 2, this will be 1. What I'll do crisscross. What I'll get? CaOH twice. Understood? So like this I'll write calcium hydroxide. Now carbon dioxide. Carbon dioxide means carbon and dioxide means 2 oxygen. Okay, giving you calcium carbonate. Calcium is what? Ca plus 2. Carbonate is what? CO3 minus 2. So plus 2 minus 2 get cancels and if the formula becomes CaCO3. Okay, so it becomes CaCO3 plus what is water? Water is H2O. Now you have to balance this equation. Now you have to balance this equation. See if the reaction is balanced or you need to balance the equation. Calciums are how many? Here calcium is 1. Here calcium is 1. Hydroxides are 2. Here hydroxide, sorry, oxygen is 2. Oxygen 2 plus 4. Here 4. Here oxygens are 4. Then hydrogens are 2. Here hydrogen is 2. Carbon is 1. Carbon is 1. 4. Okay, so this is taken in 1 mole. Okay, so for 1 mole, so if you take 2 moles, everywhere it will be 2 moles. So it is a balanced equation. So it is a balanced equation. So so I have written it in the, so everywhere if I take 1 also, everywhere I have to write 1. If I take 2, then I have to write 2 because it is a balanced equation. Okay, so we'll go for the next one. Zinc. Okay, zinc is Zn plus what is silver nitrate? Silver nitrate is AgNO3. Okay, giving you zinc nitrate, that is Zn. Zn is what? Plus 2. Nitrate is NO3 minus. Now write the charge. This is 1. So crisscross. So it becomes what? ZnNO3. twice. Okay. So ZnNO3 twice. So this becomes ZnNO3 twice. Plus silver is what? Ag. Now just see, balance the equation. So Ag, it will be 2 Ag. Okay, silver, you have to take 2 Ag. Now this will become what? 6. 3 to 6. Okay, so this will become 2. Now just see here what I have done here. What are the number of oxygens here? I'll just take another color. Number of oxygens here are 3. Oxygen C, Zn is 1. Here Zn is 1. Then Ag is how much? Ag is 1. Here Ag is 1. N is 1. N is 2. Then oxygens are 3. Here oxygens are 6. So you have to balance the oxygen. So if I take here 2, it becomes 2 Ag. Here, then I have to write 2 here also. Then it becomes 2 Ag. Then nitrogen becomes 2 here. Then nitrogen is already 2 here. Then oxygen 3 to the 6. So this becomes 6, this becomes 6. So now it is a balanced equation. So like this, you have to balance, you have to see, okay, which is, okay, where the number of atoms are less. Next, we'll write for aluminium. Aluminium is what? Al plus 3. So aluminium, Al plus copper chloride. Copper chloride is Cu plus, okay, and plus 2. I'll write how to write copper chloride. Okay, I'll just show you first. Copper chloride, copper is Cu plus 2, chloride is Cl minus 1. This is 2, this is 1, crisscross, it becomes CuCl2. So copper chloride is CuCl2, giving you aluminum chloride is what? Al, aluminum is what? Al plus 3, Cl minus 1. So 3, 1, crisscross, this becomes AlCl3. So AlCl3 plus copper is Cu. Now check the number of atoms. Check number of atoms. Aluminum is 1, aluminum is 1, chloride is 2 here, they are 3 here. Now how do we balance it? I'll write here, I'll take 3. 3 to the 6, here I'll take 2. So this becomes 2, 2 to the 6. Now here again aluminum should be balanced, so again 2. Now copper here are 3, so this should be 3. So like this, you have to check for each element, metal, and then you can just go on writing trial and error. So balancing equation means it is a trial and error method. Okay. So like this, you have to write. Now we have left with one more. So one more, barium chloride. Barium is Ba plus 2, chloride is minus 1. So it becomes BaCl2 plus potassium sulfate is, potassium is K plus, sulfate is SO4 minus 2. So 1 and this is 2, crisscross. This becomes KSO4 twice. Okay, so this is K. So to balance this K, SO4 minus 2. So I have to take 2 K. So it becomes K2SO4. Okay, K2SO4. Just a second. Yes. See here, how do you write it? So K plus and SO4 minus 2. So this is 1, this is 2. So crisscross, this becomes what? K2SO4, right? So it becomes K2SO4, giving you barium sulfate is Ba plus 2 and SO4 is minus 2. So this becomes BaSO4 plus potassium chloride is K plus and Cl minus. So it becomes KCl. Now we have to balance it. Okay, now we have to balance it. How do we balance it now? Barium is 1, chloride are 2, here chloride is 1. So I'll write here what? I can write here 2, right? 2 KCl. Now KCl's are K2. Both here are same. Then higher this oxygen. So is it balanced now? Just check. It is balanced. So it is a balanced equation. Yes, so it is a balanced equation. I hope this much is clear. Clear till here. What all we have taught you till here. Okay. Next, write the balanced chemical equations for the following. Identify the type of equation in each case. Again, you have to write the balanced equations for the following. Okay, how do you write it for this? Potassium bromide. Potassium bromide is what? KBr, which is aqueous, plus barium iodide is Ba. Okay, Ba plus 2, iodine is -1. So I'll just see how do you write it. Every time you have to write the formula here. Now KBr, I'll show you stepwise. Okay. Now potassium is what? K plus. Bromide is what? Br minus. So +1 -1 get cancelled. So it will be KBr. So I'll write what here now? KBr aqueous. Okay, plus. Now barium iodide. How do you write barium iodide? Barium is +2. Iodide is -1. So +2 -2 different charges. So I'll write the 1. So I'll write crisscross. It becomes BaI2. So it becomes what? BaI2 aqueous. Giving you potassium iodide. Potassium is K +1. Iodide is -1. Okay, so +1 -1 get cancelled. So it becomes Ki. So it's giving you Ki aqueous plus barium bromide. So barium is Ba +2. Bromide is Br minus. So sorry, I'll just show you stepwise again. So Ba +2. So this will become 2. This will become 1. So crisscross, it becomes BaBr2. Okay, so BaBr2. Can you tell me what type of reaction is this by seeing the? Yes, can you tell me what type of reaction is this? Decomposition reaction, displacement reaction, double displacement reaction, combination reaction. What type of reaction is this?
Double displacement.
Yes, it is a reaction, double displacement reaction. Okay, so what is getting displaced here? Your Br is getting displaced, sorry, your potassium is getting displaced, your Br is getting displaced. Okay, with Ba it is getting, and K is with I. Okay, so double displacement, right? Double displacement reaction. So we'll go for the next one. Next, zinc carbonate. Zinc is what? Zn plus 2. Carbonate is what? CO3 minus 2. So +2 -2 get cancels and it becomes ZnCO3. So I'll write here ZnCO3, giving you zinc oxide. Zinc is again +2, oxide is O minus 2. So +2 -2 get cancels and it becomes ZnO. So it will become ZnOS plus carbon dioxide means O2 gas. Now what type of this it is? Reaction ZnCO3 giving you ZnO plus CO2. This is double displacement reaction. What is the second one? Which is our...
Decomposition.
Yes, it is a decomposition reaction. It is a decomposition reaction. Okay. Then hydrogen. Hydrogen is what? H2S. Okay. Plus chlorine. Chlorine is Cl2 gas, giving you 2HCl gas. Yes, this is what type of reaction? Third one.
Combination.
Yes, it is a combination reaction. It is a combination reaction. Our last reaction. Okay, magnesium is Mg. Magnesium is Mg. Okay. 2HCl, hydrochloric acid, aqueous. This is solid, giving you MgCl2 plus H2. Okay, so here what is getting displaced? Your hydrogen is getting displaced by Mg. So it is a displacement reaction. So this is a displacement reaction. Okay, so this is a displacement reaction. So some more 9, 10, 11, still 2, 5, 6, 7, 8, 9, 10, 11, 12 questions are there. Okay. So those 12 questions will solve in the next class. So in your schools, is this chapter completed or how?
Yes, ma'am. They have
Completed. Then chemistry, they have started the other chapter, next chapter.
Yes, ma'am. They have completed acids and bases.
Acid and bases and salts is also completed.
Yes, ma'am.
Then you have started metals and non-metals.
No, ma'am, not yet.
Okay.
We're actually doing physics chapter now.
Okay, okay, fine. So for your exams, what all chapters you have? When you have your exams?
24th.
24th, ma'am.
July.
Yes, ma'am. This
Which
month.
chapters are there for exam?
Ma'am, 3 chapters. One from biology and 2 from chemistry.
Okay, you have acid, bases, and salts also. They did not start bio. Okay. So then I have to do the complete exercise, or you want me to start the next chapter? Only last 12 questions are there. I will require one more class and I'll finish it. Okay. So after that, only one class, I'll finish the exercise part. Then we can start with the new chapter. Okay. Not hurry. So we'll do it. Okay. Okay. Then we'll stop the class here. Okay. Thank you. I'll just end the class. Okay. Thank you, dear students.